Swayam Prabha. Digital India. Educated India.
So now we'll continue our discussion on these elements of mechatronic systems. Last time we had seen some sensor elements, right? Remember these? Like you can have a look at these. Okay, so let's flash through these slides and go through. Okay, so last time we had seen these different elements of mechatronic systems, and then focused on our sensors, and seen some of the classifications of the sensors based on the analog and digital output, and based on the principle of operation of the sensors. Okay, so in today's class we will continue a little bit of a discussion pending, which is on the MEMS sensors, so which are kind of these days more popular for many applications because of their cost advantages. So the MEMS refers to micro electromechanical systems. Okay, they are fabricated by IC technology. Okay, you might have seen these foundries where these people wear this kind of a dust-free clothes, and then enter the foundry and then fabricate the chips. So in the chips, usually like computer chips will have only electronic components. Now if you can imagine, if your computer chip will have some kind of a mechanical kind of components, then it refers to this MEMS technology of bulk fabrication of many sensors at a time on the surface of a wafer. Okay, so because you can fabricate maybe thousands of sensors in one kind of a process, its manufacturing is very easy. Manufacturing cost is very low. Okay, manufacturing may not be so easy because it undergoes VLSI processes, which are kind of based on the equipments which are costly equipments. So the advantages here are you can have integrated fabrication of sensors with both mechanical and electronic components on the same sensor. Then low cost of fabrication. Let me see if I can get a pointer properly. Laser pointer. You can see low cost due to mass fabrication, and the techniques and processes can be designed to create really small systems. Okay, so this is very interesting kind of area of application, or area of research also. There are many interesting systems that can be developed based on this MEMS technology. Okay, and one should be aware about this. Okay, some of the, maybe we can reserve some separate lecture on this actually at some point in the future classes, so where we can demonstrate some interesting sensors and actuators also in the MEMS based technologies. Okay, for now we'll kind of go forward with other kind of topics that we would like to see here. Okay, so this sensor selection, again we'll come to this topic later on also, but we need to have some kind of a common sense understanding for sensor selections. For example, if you want to kind of get sensor selected for a given mechatronic system, see, this is like a evolving design process, is iterative and evolving. Okay, so you cannot immediately come up with the specifications of the sensor, but you will have some kind of idea. Then you change the start developing first kind of a design. Then with the analysis you find, okay, well, we need to fine tune some specifications. Like that, this like a design is like evolving process for mechatronic systems. So we have to go through this kind of a evolving process. We may not have all the details at a one go, but as we start thinking about applications, like, we will get to know more and more details, and then we can incorporate them into the requirements, and like, development, selection of the sensors and things like that. From the system's requirement perspective, you need to kind of get to the sensor requirements. Okay, so that process is maybe somewhat like, based on prior experience, or maybe based on some mathematical analysis. There are many different ways we can do that. Okay, and again, iterative way it will go. Okay, so we'll go through this kind of a process sometime later, but these are some kind of issues that one needs to be looking at for selection of sensors. Okay, then second one is a noise consideration. So if you are doing the analog sensing versus digital sensing, you need to worry about the noise in that way. So you may need to filter, or you need to take care of the noise in analog domain, or in the digital domain. Okay, so for example, if the wire or the sensor is already giving some kind of a noise before even getting into digital domain, you may pass the sensor output through some analog filter. Okay, some simple RC kind of a circuit will take care of that. Then you of course you'll have a cost implications with this. Then mathematical modeling is going to be important for simulations, to kind of come up with precise specifications for your sensor. And then you typically go through manufacturer catalog and match the requirements, whatever you have generated, the sensor requirements. You need to be matching with manufacturer's catalog, and getting like, selecting a proper sensor. Okay, so that is a kind of a process that goes on for the sensor selection. Okay, so we will do this process sometime later, but like, you should be aware about these parts here. Then we have a next element, which is actuator in the system. Now for actuator, we have lots of different kind of choices. So from the mechatronics perspective, now I'm not kind of really talking about only like, many kinds of different kinds of actuators that are found in the in the literature. Okay, we can have actuators which are like, I would say, servo controllable. Okay, that is what is important here. So there are many actuators that can be servo controllable possibility, but these are like, some of the most popular kind of actuators. So solenoids is one of the important class. They are used in mainly like, push button, like, they are not servo usually. So solenoids are not a servo actuators, but they are like, digital on or off kind of actuator. Okay, so they are used in many kind of mechatronic systems, especially the process industries and things like that, where you want to suddenly open a valve or close a valve, which is not, it's like a digital opening and closing, or you need to remove the articles or parts from the conveyor belt, which are not really suiting you need to reject the parts from the conveyor belt. Okay, that kind of actuation one can do by solenoid. So many different places they have applications. Okay, then AC or DC motors, these are like, very important class, because they are most popular actuators in mechatronic systems. Then you can have stepper motors, also a big class. And then for the systems which are very heavy, you'll have which have very high power requirements, you'll have hydraulic actuators. And nowadays, like, very precise applications, piezoelectric motors, for example, autofocus cameras or DSLR cameras will have these piezoelectric motors for the motion of the lens. So you can see that very interesting sound that comes when you when the lens is focusing in your SLR camera. Okay, that is because of these piezoelectric motors. Then you may have pneumatic actuators also possibility. Okay, so we'll go briefly through each of them, and not so many details, but as we go along we'll get into more and more details. So this is a motor which is DC motor, along with the encoder here. So this is what we'll probably use for our programming, or learning the practical parts of the system. Okay, so with the TIVA board we'll use this kind of a motor with the encoder attached to it for understanding some of the fundamentals of control that this course has to offer. Now coming to the DC motors, so this is, the principle. There are two primary classes, which is brush type and brushless type. So brushless types are where you use it for the applications where you need a high speed, and then wide variety of these motors are available in the market. Okay, the very high precision manufacturing or very high quality motors you'll find from the companies like Maxon or Faulhaber. Okay, those kind of companies will produce these motors which are very very good quality motors. But otherwise also, there are many companies in the market where these motors can be available. And speed, torque ranges, size, voltage ranges, you'll have a lot of variety you'll find with the DC motors. Okay, then stepper motors are another kind of a popular actuators for mechatronic systems. We'll see some of the applications soon. They are used in the places where you don't need a sensor. Okay, so you can rely on the steps, saying making sure that the steps are not missed in the drive based on the capacity. So you choose a motor of a capacity that the steps would not be missed, and you are kind of simply give so many number of steps, and the application will be running smoothly. If there are external loads which will prevent the steps to be slipped, then these actuators are not really really good. Okay, so you need to make sure that the torque that is required for the application is not higher than what your choice of the motor. So motor should be delivering higher torque than what application needs, then it should be fine. And the stepper motors also have this kind of a holding torque which eliminates the need for brakes if at all some application requires that. Again, there are several constructions and configurations possible, so we'll get into some more details, but we'll give some kind of idea about how they work. For example, here, so this operation principle is very simple. Here you excite one coil, and then you excite the next coil, the rotor will move to the next position. Okay, and then you'll have a sequence of excitation of different coils. There are typically 4 coils in the stepper motor: 1A, 1B, 2A, 2B. There are the standard kind of a terminology that is used there, and these operate in a very many different logics that can be possible. So for example, in this case, maybe I'll show you the animation of the logic. Okay, so you have only one single kind of excitation happening at a time now. Okay, so this is one kind of a mode of operation. Okay, it's called full step kind of operation. Then if you see, if you want only half of this step to be happening, so what we can do, can you think about? Okay, for example, one of the ways to kind of get to these micro stepping modes. Okay, there are different these micro stepping modes can be possible. One of the ways to get to that is you control the voltage itself on each of the coils. Okay, so I'll tell you how we can control the voltage and do that. When we see this half step mode, you may understand things better. Okay, so half step mode, you'll see this is the kind of thing that is going to happen. Can you see that? So you excite one coil and other coil next to it, uh, both together. Okay, so we'll make the position of the rotor into some kind of a middle position here. Okay, now if I want to change this middle position to either side of this coil or side of that coil, I can excite these two windings differentially. Are you with me? So you should think about, okay, how can we have some multiple steps possibility between the two half steps. Okay, so this is one half step up here and other half step. Okay, or within one full step. Okay, how can I have more steps than half step possibility? Okay, so think about that. It's very interesting way you can see that we can operate stepper motors to kind of give you really high resolution, although the steps are designed, or the motor is designed to kind of give only this single step or half step or something. We can possibly, by changing the control, or by changing the amount of energization of one coil versus other coil, one can kind of have many different possibilities. Okay, so we'll look at those possibilities again in the future when we deal with more details about actuators. Okay, there are these different applications of stepper motor, dot matrix printers. Nowadays, these are extinct now. You might not have even heard of this name of dot matrix printers. Okay, floppy drives also are kind of extinct. It used to be in the past. You have like a magnetic disk, and you can drive things by, store the data on the disk, which is nowadays all replaced by your pen drives. Then a lot of robots. We will have many different applications. Okay, so we'll see some of them. CD-ROM drives there are some interesting ways stepper motors have been used. Okay, now we look at little bit of hydraulic actuators. So in hydraulics you can have two possibilities. One is like a linear actuators, or you can have hydraulic motors also possible. Okay, so we'll see how hydraulic motors can be made to work actually. So we'll see that. Hydraulic actuators would be useful in the places where you need very high force, and you need very high torque in very small kind of a compact environment. Okay, however, they are as the name suggests, you need some kind of a fluid that can be giving this pressurized fluid, which can be giving this actuation. So you need this entire system of oil tank and oil pressurization and things like that. Okay, so that entire system needs to be there together. Then you'll have very high forces and torques in a small place. That can be possibility. Because of the high torques, naturally they'll be very fast. They'll having relatively low inertia and very fast response. Okay, there are many different hydraulic motors possible with the principles, the vane motors is one of the ways that you can have hydraulic motors created, or you have axial piston motor or swash plate motor. Okay, so you just Google about this and you'll see how these motors, these hydraulics are working. Their applications will be mainly in the conveyor belts or earth moving machinery. Okay, like big machinery where you want to kind of dig out some things, and those very high forces are needed. That's where you'll use these hydraulic actuators. Okay, so this is one of the open up picture of hydraulic axial piston motor. So you can see that pistons are up here, and they are operating this swash plate here. This swash plate is like a rotary plate with pistons which are coming at an angle. So you can imagine when this piston is pushed here, the torque which will be created will push the shaft. It will rotate the shaft in this direction. Okay, and once that piston is in its end position, then like the hydraulic force will be removed here, and then the next piston will be operated. Okay, and then the next piston in this position will be again pushing this to the end position, and again this operation continues with multiple pistons that are there, and the way this motor is rotated. Okay, so very high force can be applied here with the high pressure of the oil that is there in the piston. Okay, and then that can be controlled in by using some hydraulic servo valves. Okay, so that is another kind of element that will be needed in the system to, that is our electromechanical interface to these actuators. Okay, all right, some applications here. Okay, the last element, okay, is controller. Okay, so we'll talk briefly about controller. Again, I'm just giving you somewhat brief overview of things. We have to talk a lot more details as we go along in the course. Okay, so but this is some kind of a like brief idea you should have in your mind to kind of slowly start understanding like more and more details about. Okay, so or you may raise the questions based on these to think about, and then like we will take up these questions as we go along. That will be a good way to kind of understand things better. So controller is also a very important element of a mechatronic system. Um, so wise controller design, okay, can lead to substantial savings in the cost. Okay, um, so we'll see some examples and understand this point. This is very important point that we need to be aware about, that the way you design control, okay, would have a lot of cost implications. Okay, um, see controllers, for example, used in used in hard disk drives. Okay, they have been designed to kind of perform really well in a with a so which will not demand a lot of investment into the sophisticated nature of the arm that is there for the hard disk drive. To see this arm positioning on the surface of hard disk drive is extremely precision, high precision kind of application is required there. But the way the controllers and in general mechatronic system is developed, like you can have that at a very low cost that can be possible. um, Maybe we'll have some chance of looking at hard disk drive a little more in detail as we go along. uh, then there are different kinds of algorithms that can be possible. Okay, so some of the algorithms are listed here, but they are not a complete list. You'll have lot of possibilities in this domain. Okay, tons of papers, tons of literature is published on the control algorithms for many different applications. Then you can have types of algorithm based on the implementation class. Okay, so you can have analog domain implementation or digital domain implementation. Like that, you can have controller developed in different domains. Mostly, like when we talk about mechatronic system, we'll chiefly consider this digital domain implementation by using microcontroller or microprocessor. And analog domain also is possibility, but we will see, like whenever like we have some simple kind of controllers implemented, then like analog domain can be okay. Some kind of a PD PID kind of controllers we can implement by using these op-amps, basically op-amp circuitry. But then we cannot change the gains on the fly. There are some disadvantages to the system, but as long as we know that okay, this is what we want finally and this is fixed, it's not going to change ever, then like analog domains controllers are not a problem. But digital domain nowadays, like are available at very low cost. Of people I don't think are going to the analog domain kind of circuits these days. Only advantage analog domain will give is like the continuous domain implementation or application. Okay, which is not possible in digital domain. We need to have some kind of a sampling done for getting the digital domain implementation in place. Okay. So there are some design and analysis issues for controllers which we'll have to again deal with anyway in the great details later. Okay. So I think maybe we'll stop here.